Oh. My go-to calculus book is the calculus book when I first took calculus. I mean, it's the best one because it's the one I learned from, so hey, right? But I always go to that if I want examples or a different way to explain something. It really evolves. The way they talk about things, it evolves so much. I mean,
I keep the things that I need, but some things I'm a holder by nature, right? I have tons of stuff at home.
You're not to the point where they're going to put you in the program, are you? You have to like climb into your living room.
Maybe, who knows?
Maybe.
Should be on the TV show.
You have people that you forgot about underneath somewhere.
There's a corpse in there too. It's one episode too. It's weird.
Huh?
This lady, she was a hoarder, right?
Yes.
After they clean all her stuff, there's a dead body in the room.
No, come on, stop.
It's real.
All right. That's what happened to our neighbor. Came over for sugar and never left.
I just dropped.
Huh? I don't know. It was up there, so I finished the equation. Couldn't stand it just having no other side. So we'll let the AOJ people that come in later have fun with that. They always make fun of mine if I leave some equations up. They're like, "Oh, look at that shit! I remember that shit." I'm like, "Oh, look at that shit." I wanted to look at. I think this is one in the book somewhere. I want to look at this guy because. I like to give you problems that force you to use the idea instead of the shortcut, right? And actually, sometimes I'll like, no, don't use the shortcut, just because I'm being an asshole, but also because you got to stay in touch with why things work.
Is that why you gave us number 18?
Yes, could be. Yeah, 18's a bear. I understand, but oh well, you got to do a few of those to get through. Build up some stamina. So. What would I do for this guy, for example? What form is, what? Yeah, why? Why is it y equals x to the n? For yeah, the degree of the polynomial pieces matches with the order of the terms. I like it. And you can't just go straight to the auxiliary because that auxiliary that we have memorized, the b minus a business, is for a second degree differential equation, so it's not going to work here. So you got to do 3. Can we just jump to this? What would this be?
X cubed.
M.
Oh wait, just
M minus 1.
M minus 1. Yeah, that would be first, second,
M minus 1.
x to the,
N minus
Minus 3.
3.
yeah. First derivative would be m, second derivative would be m minus 1 in addition to that, third derivative is m minus 2 in addition to that. So now when you throw this stuff in, the x cubed fills that in. You get m minus 1, m minus 2, minus 6. I've already divided by x to the m. Is that cool?
Yeah, that's fine.
Right. And now this is what you work with. I love the people that add 6 over and say m is 6 or m is 7 or m is 8. Right.
Multiply everything.
Yeah, you gotta multiply the sucker out because it's not factored.
So
You gotta
much
suck
faster
that
than
in.
I did it.
Huh?
That's so much faster than the way I did it.
Oh, what'd you
Did it
do?
like they're really, really, really long where you just distribute.
Oh my god, dude. Oh my god. Yeah, get rid of shit as soon as you can. So it's not like carrying, especially when you got a lot of pieces to carry it through. So yeah, this will be m squared minus m.
Minus 2.
So then you get m cubed.
Plus 2.
What's up? Minus 3m squared
Those two.
Plus 2.
plus 2m minus 6. And that's factor plus nice. Right? Is that cool? All right. So just realize I'm going to give you a problem where you have to use the true thing, not just the shortcut that it leads to, because the shortcut it leads to in this instance is only applicable for second degree. I like it. And then just to fish, what do you get when you factor this? You get m squared, m minus 3, plus 2, m minus 3. What really sucks is I wish teachers would keep factoring alive more for you, because at this point you should have developed a ton of ways to make factoring quick. And what normally happens by the time you get to this level is you haven't done any factoring in so damn long, you're like, what are you doing? Give me a cube, Jeff. It's mean. It's a grouping problem. Holy shit. Right? I've had people come up to my desk and like, what are you? What? Cube? I'm like, just step away, man. And then here you get M is 3, or M is plus or minus
Do I?
I rad 2. You got to square root the core 2, too. Yeah, and then of course, the form that leads to for the answer, yeah, x cubed. Then what I was saying earlier is if your DE has x's in it, Cauchy-Euler, your answer is going to have x in it, x to a power.
Don't you need a C1 right there?
Yes.
Yeah. Plus,
C2
yeah,
cosine
yeah,
square root ln x. Square root 2 ln x. Sorry.
yeah. Square root 2 ln x plus
C3
sine
root 2
ln
ln x.
x. Okay. I like it.
Isn't it multiplied by?
Multiplied
I
by,
thought it was x to the alpha times the quantity of.
yeah, what's alpha?
It's 0.
0.
Oh.
So it's actually
I
0 is
thought
1.
3 was the. My bad.
No, sorry.
Yeah.
Yeah, these are separate. So alpha plus or minus beta. Yeah, beta is good old, yeah, is there. Alpha's not there. All right, I like it. Okay, what about this guy? Maybe I'll do something on that. I don't know. Take that away.
N times n minus 1.
And a cube?
So is that one the same idea as this one?
Oh, yeah, no, it's not.
No, no x's. It's not Cauchy-Euler. It's the easier situation because now we're dealing with
Just enough.
each BMX's, which are nice derivatives, so I don't have such weird b minus a kind of shit going on, or mn minus 1, n minus 2. So it just goes directly to what auxiliary. And if you really are being nice to yourself, you really should kind of, before you do anything, put this here so you can reference it later. Over here you put y equals x to the m, so you can reference it later. And what do you do from there? The incorrect thing is to subtract 8 and take the cube root, because then you only get the real answer. You know there's 3 answers to this. There are 3 distinct m's. Now you do. This is what's called the... Do you guys know F-talk? 1 and F-talk 2, the fundamental theorem of calculus 1 and F-talk sounds like, hi, welcome to F-talk. It's like, shut the fuck up. No, no F-talk, no F-bombs, except for that one. Dean, if you're watching, fuck you. Yeah.
Could you just assume one answer and then do synthetic division at that point?
Oh, no.
Obviously.
Oh, I see what you mean. Sure, of course you could. You could always do synthetic for factoring. Synthetic is a general factoring tool, but it's like one of my teachers said, it's like using a sledgehammer to open a walnut. It's a little much for certain situations. Hopefully this would be one of those. So FTOA is the fundamental theorem of algebra.
Number of roots equals
And that, yeah, exactly. The number of roots equals the degree of the problem. It's just that two of these roots are going to be complex. So you got, when I teach this, it's little dude, big dude. And when I teach cubes, I relate it to Pulp Fiction. Does anyone know how to put this thing together?
And then plus 2.
Yeah, you put one of each in the little dude because it's a little dude. Then obviously you got to put 2 of each in here so that you get 3. You get all this extra shit though that you need cleaned up. So you call the cleaner. If you've ever seen Pulp Fiction, you know the scene I'm talking about. Brains and blood on the back of your car seat. You better call somebody that knows what to do, hose you down, get some coffee. That's going to be this guy. He's got to be opposite sign so he can clean shit away. And then 2 times m is what works. All right, anyway. Or you can do synthetic. I'm fine with that. That's a nice, valid way to do it. Now here, so you get one real answer, and then this you use quadratic. And I don't want to do that. Use quadratic, you get the other 2. Cool. I mean, so just, you should know me a little bit by now. I do bring back old ideas, not because I'm being mean, but because they have got to stay alive. We're going into math-intensive stuff. it's important to make that connection between old stuff and new stuff. Anyway. Is that decent enough? You're getting your complex numbers here. The answer is going to be in this form, and the complex ones are going to become cosine and sine without all that natural log shit in there, right? All poor little dude. Okay. I don't care about the last guy. All right. So I wanted to talk about those real quick because it just kind of came up earlier. Anything specific you guys want to address now? And then I want to do the last two problems on the practice test because I didn't put them on the answer key.
So just so far we didn't do any direct substitution on this stuff. Are they going to be in this exam? I think they're not on the homework now.
No. I think it did happen earlier this semester. Or it could have happened, but it didn't because you can memorize what certain things are. A trig sub is not something that happens very often, but it does happen. But I'm not going to throw a trig sub at you all of a sudden without getting you ready for it. So.
Just like I said, like.
Yeah. So in the final, I might do a little trig sub review.
Oh gosh.
Not really.
I'm golden on that.
Number to the x,
Say again?
we like 3 to the x, power x.
3 to the x. What about it?
Like, and instead of x to the power 3, it's like, let's say 3 to the power x, so it's making the entity more hard. Like, you have to memorize it.
Oh, the antiderivative of 3 to the x?
Yeah, or even like the integer.
Yeah.
I mean, like, until now, in the homework, we haven't seen something like that.
Oh, yeah, I see.
So I just really have to forget the, like,
I'm with you on that.
Or the weird, like, derivative stuff.
Well, real quick, what's the derivative of 3 to the x?
3x divided by all of
forget.
30. So derivative of 3 to x times all of 30.
Yeah,
So the antiderivative of that is
and because e to the x prime would then be e to the x times ln of e, which is e to the x. And so the antiderivative of 3 to the x, or otherwise known as integral, would be
3 to x divided by all of
divided by. To kill the ln3, that would want to come out, right? Okay. I mean, that could certainly show up. Because it's just a derivative of what we should know. It really is. It's related to e to the x. It's not that far away from e to the x.
How about the square root of 1 minus x squared? That was one of the homework problems.
Real quick, before I get too far away from this. Say you have, so y is 3 to the x, right? So what's x equal to?
Oh no.
So let's see how we get there. We take ln of both sides, right?
Yeah.
So the x comes down, so you get ln y over ln3. Cool. Right? Or you could do like ln y equals x ln3. Is that cool? So what's the derivative of both sides now?
1 over y. X.
Yeah. What's the derivative of x ln3? ln3, because ln3 is just a constant, right? So y prime is then y ln3. What's y? 3 to the x. I mean, that's where that rule comes from, right? Just to remind you guys. I mean, you've been shown this before. It's just been such a long time ago.
That's what I'm saying.
I know. But what's more important than looking at everything you've ever done as a series of facts to remember is that you're developing processes so you can do it again yourself and not have to memorize every damn thing, right? So implicit differentiation is a powerful tool to do a derivative of a function you don't know based on a function you do know by rewriting it. Yeah. All right, it's enough of that. So, tonight's review day. Hopefully you guys remember that. I'm not going to do anything new tonight. We're going to go over, so if nobody has any questions at the moment, I'm just going to go ahead and we're going to do those last two problems because they're not on the practice test answer key. Anybody else still need a practice test? Okay. If you still need your group quiz, see me at the end of class. Let's do. So I think it's 4D I didn't do. So you guys try to get as far as you can with that. We can give this out. So who's here? Daniel, William. Oh, there he is. Yeah, it's right there in between the camera and the drag. Travis. Jose. Yesenia. Teresa. I guess everybody. All right, everybody got their quiz back? So I'm going to make that group quiz worth half a normal quiz, but you can make corrections still do the daily test. Let me make sure you guys got the first thing. What do you do first?
Your A, your B.
Nope.
X equals
M squared.
So it'll be your AH, right?
4D.
So it should be homogeneous. Why do you have to do this first before you do the A stuff?
Make sure your Y of C doesn't equal.
Yes. Make sure there's nothing in your YC that's a function that is here. So otherwise you have to multiply by factors of X until you get it out. You get it out of there. Hopefully that makes sense. And then from your I, you get your ox. So your associated homogeneous, it makes it equal to 0. What's the auxiliary from this? It's not m squared plus 1 m, right?
Right.
Minus 9.
Yeah, because it'll be b minus a, so that's 0, minus 9. M is plus or minus 3, so I get y. C is,
C1 X cubed
yeah,
plus C2 X cubed.
kick ass. All right. Thankfully neither of those is over there. I like it. Now you can do your whole A, it's just B stuff.
Do you have to worry about the duplicate theorem before you find the function of f of x?
Yeah, before you start doing yp equals and writing the general form, you have to know what these are, so in case that these are part of what the general form wants to be. If this was 4x cubed, what would I have to do? Yeah, 4x cubed would want the thing to be ax cubed plus bx squared plus cx plus d. We then have to multiply this whole thing by enough powers of x until none of it has x cubed in it, right? Do you guys remember this? So that's why you have to do this first. So if this would have been 4x cubed, this problem would have been much more heinous, right? Much heinouser. So that I have to multiply, if I just multiply by 1x, that's 4, 3, shit, 2 x's, that's 3, shit, 3 x's, that's 3, shit. So I got to multiply by 4, x to the 4th, just to make sure that nothing has x cubed in it. Funk-e-delic. So thankfully, that's not the case. Right, so how do I, what's yp, what's the form of that going to be?
X, A, X, plus B.
Who?
AX.
Yep. Now, some of you guys might still be like, well, there's no constant there. Why do I have to assume a constant? Because this could cancel because of all the mixing of the derivatives. So you have to cover your ass for what could be there. Does that make sense? I mean, that's okay, hopefully. So now you can just do the beautiful thing about this is that the second derivative is going to be 0. Yeah.
If there's any specific thing, this question that we have to solve it by this method, like I find it to solve it by 4.6 is easier.
Oh.
Or skin?
You could do 4, 6. Sure.
Okay.
So all right, so 4, 6 would involve assuming u1 x cubed plus u2 x to the negative 3, and then doing your Wronskian and your u1 prime. So if you consider that to be easier,
Okay.
I love it. I just don't hear that much, right? I don't know, I didn't do it that way. Here, y prime is a, y double prime is 0. So you just end up with, is everybody cool? What's happening?
Yeah, AX prime.
So you end up with ax minus 9ax minus
9B.
equals 4x. So b is
0.
0. Negative 8a equals 4. So a is negative 1/2. I'd say that's pretty quick. I don't know.
I mean, just like sometimes it depends on the form, right? Forms.
Oh, I see. So in general, you mean, not for this one, but in general, maybe there are some that it's quicker to do that way. So I'll accept that. So then your answer is,
C1.
yeah, C1, C2 plus, well, actually in this case,
Negative 1/2 X plus.
negative 1/2 x. B was 0, right? B just happened to be 0. In general, it could be something else. I like it. Now, some of you guys, if you do enough of these problems, you start to see where you can start losing some things here based on what's going on, but if you're not there yet personally, then I wouldn't start doing that. There are certain situations where you have cosine and sine, you can just forget about one of them based on what derivatives are present in there. Not always, not obvious very often, but there's some situations. So the more of these you do, the more you can truncate this. Okay. So that's 40. That wasn't too bad. I don't know if anyone's tried 5 yet. Yeah. 5's going to take some room.
Where did you get B equals 0 from?
Oh. Because the only constant term is this, and it's got to equal the constant term on this side. Yep. And then these are the coefficients of x, so they got to equal 4. I like it. Yeah.
How come our auxiliary equation is not m squared minus m minus 9? Is it because we're assuming on the right side there's only...
What's b? 1. What's a?
is
1. And then the middle coefficient is b minus a. So that's why the middle term is gone. Yeah. I like it. So you know I'm going to mix stuff up. I'm going to have one section which just says, solve these, A through F, or whatever. If you want to, you can find all the ones that you know are definitely Cauchy-Euler, and then you just have that one idea so that you're not like shifting gears. Because that's where people go, I just did x to the 7th, and now this is going to be x squared. No, it's supposed to be e to the 2x. Ah, shit. You know, it's really simple. Once you get an m, your brain just kind of goes down a path, and you're like, sounds good to me. You guys don't know what I mean? I mean, I'm sure it's happened to you. It's happened to me this semester, I will admit. Thankfully, I catch it pretty quickly, but I go, oh shit, that's easy. All right. So let's look at 5. You probably, based on the other problems in here, I don't think any of them were where you had to multiply by some power of x. And then you get to number 5, and you're like, well, this has got to be where that happens. There's got to be at least one of them on here. Yeah. So, of course, first, yep, you do your H, your ox. Is this Cauchy-Euler or no? No. This is an easier ox. All right, so what do you guys get from this?
That makes plus or minus.
C1 cosine ln x.
Yeah, so you got C1 sine
4x.
4x.
Cosine 4x.
Yeah, there's no ln because that would come from Cauchy-Euler.
Damn.
Question.
So in general, without the x in front of the y term or degree, no, it's not Cauchy-Euler, right?
If there's an x coefficient,
Yeah.
then it's very likely Cauchy-Euler, especially for this test.
Yeah.
Right. In general, but I mean, in general, if the x coefficients powers match the order of their terms, then that's Cauchy-Euler. If there are no x in your any coefficient, if they're constant coefficients, that's your e to the mx stuff, which is beautiful.
Because sometimes you can just divide by x, right? In earlier chapters.
Well, I mean, if you have certain forms like linear, something where you can find an integrating factor, yes, you can divide the x away. But this is the higher order DEs where you don't really do that kind of stuff directly. Okay, so what's unfortunate for us?
It's part of it.
Yeah, shit. The form I want my YP to take would have this, therefore
X.
that's no good, right? So I want my form to be a sine 4x plus b cosine 4x.
Can we go over how to make that out again?
So, so again, just to reference you back to where this first comes from, is that table? Yeah.
Yeah.
But the idea itself is just, in order to be like terms with its second derivative, it's got to be sine and cosine. Those are the things that are like terms. Now E would work also, but You see what I mean? E would work also, but this is second derivative related to its first. I mean, it's got to be sine and cosine. Now, more importantly is it's this guy, right? That's what's driving us. But the reason that that assumption works is because both of those have derivatives that include sine 4x in them. So whatever these do together, they will have like terms including that there. So whatever else, the cosine stuff would cancel if the coefficients were right, which is why it's called undetermined coefficients. What coefficients would make that happen? Now, please, dear God, everybody understand that's the first step. It's not what we're going to use, right? And that table, again, was on page 146. So what do I have to do to this whole thing?
Multiply by x.
Yeah, so this is what we want. This tells us you can't have that. Shit. So then our actual y, let's see if they p out it. It's going to be a x sine 4x plus bx cosine 4x. Let me try to remember actually. It's the one that I always forget myself. I'm pretty sure you have to. Oh, where do they talk about that? Yeah, that's the weird part about it. Let me see if I remember this right. Okay, yeah, it is the whole thing. Okay. I always forget that myself. So now I just start. Now the very bad part about this is there's two terms already. They're both product rules. So this is the one where sometimes you might want to turn your paper this way. I've done that in many classes. Turn
He's
this
right
paper this
really
way.
small.
Tape another piece of paper on that so you can fit everything in there. That's where the instructor, that's where you have those classrooms at university with chalkboards all around the board, because you have a problem that kind of dances all the way around. And then the instructor says, over on wall 2, do you remember that's third step? Yes, that happens. So you just kind of move your chair, learn how to be an owl. So y prime,
A to 4, AX sine 4.
yeah, so a sine 4x, right,
Yeah.
plus,
ix
sure,
Minus
plus
4,
sine 4x.
AX sine 4.
sort of,
X
Four.
4.
right?
Yeah.
Good. So that's this guy, plus,
B cosine 4x.
yeah, the same thing over here, b cosine 4x, minus 4b sine 4x.
Should we split?
I don't know. B cosine 4x, 4bx, yeah. This one we're doing the cosine derivative. So the nice thing is there should be symmetry between here and here, right? Now the negatives won't match up because you got one is sine and one is cosine. And then y double prime. This is where I'm hoping, I've done this a couple times. What'll this be?
4a sine
4a
Cosine
cosine 4x. And then this would be 4a cosine 4x. All right, so let me just make that 8. If you don't like that, you don't have to do that. I'm going to. And then I have to, so I did that derivative already, so now I got to do this derivative, so that's going to be minus 16a x sine 4x. Here's a pig's ass about that symmetry thing between the two pieces. That should be mimicked over there in a certain way. So let's see how it looks exactly. So this will be minus 4b sine 4x. Then this, if I do the x, that'll be 4b sine 4x. That's minus 8b like just happened. And then I can see your face, I know, so don't do that. Minus 16b cosine 4x. So you can see the symmetry between the two.
dx. 16 dx.
Yeah, so thank you. The same thing. It's going to be my downfall. And now you just do what this says. Right? So this is where if you want to, you can go up here and do 16, 16, 16. Right? Some of you guys do it this way, which is awesome. It's a constructionist method. 16y. And now I can just add these together. That goes with that and cancels. That goes with that and cancels. So you end up with, need to be careful here, 8a cosine 4x minus 8b sine 4x equals 8 sine 4x. So A is 0. There's no cosines. B is -1. And in the original, now this is why you might not want to do that, because this is your original. What's B the coefficient of?
-1 x.
The cosine part, right? So a lot of people look at this problem, they'll say, I don't have to worry about the cosine part because it didn't have any cosines in it. Oh shit, if you do that, you're going to lead to no solution because you don't have the part you need. So now my answer, my total answer, is C1 sine 4x plus C2 cosine 4x minus x cosine 4x. And this has happened a couple times where people put these values in the wrong place. Just remember, this is what the answer looks like. You just don't know what A and B are. So once you know them, you plug them in that, because that's what the answer looks like. What else you got? Yes? You good? Okay. I like that. Did you hear that too?
Yeah.
Okay.
No,
Just you.
Thank you. That's, if you're fast enough, you could be like, "You're what, Jeff?"
We should play along.
Take all your meds, Jeff. Take too many meds, Jeff. All right, let me go ahead and give you guys the rest of this answer key. Compare with what you've done. What have you done? I'll put it in here.
okay.
Never anything in your brain that would explode.
That was my first joke in 5 years, and that's what you would make.
All right, did I do all of it?
Are you sure you did them all?
Yeah, 4C, good. And then it picked up with 4D, right? Yes. Okay.
Practice test question 2. Would you show all of reduction of order to get that to show that answer? Or would you just
No. So you see how I say, for example, if m squared, blah, blah, blah. So you don't have to do any specific. The question is just, where would the other answers come from? It would come from reduction of order. Yeah. So I'm going to try the conceptual questions I ask. It's going to be hopefully very obvious. Maybe I'll say it. You don't have to do work on this problem. It's a conceptual question. You know. Yeah. And if you did that 4-6, is that the one that was extra credit? The annihilator method? 4-5? If you did 4-6 is very strong. Shit, no. You can use that method on the test if you want. I might have a specific bonus question related to it, but if you want to use the annihilator method on the problem that you could do by 4-4's method instead, because 4-5 is an alternative way to do 4-4, and the really funny thing to me is the math in 4-5 is the same as 4-4. It's the same shit. You're just memorizing it based on the form of the operator instead of based on the form of the answer and whatever. It's the same thing. But if you like that way better and you did that, you can use that method. Does that make sense? And it will probably be very specific when you're allowed to use a shortcut or not. Yes?
Like the first three, do you have to use the row theorem?
Which one are we looking at?
4C.
4C. Oh, yeah. Why on 4C? Why must I use the variation of parameters method? And you're like, I asked the question that you just asked, basically. Thanks. So why does it make sense that I can assume the answer is don't worry about the X shit, that was extra crap, but I can assume the answer looks like this. Because sine and cosine's derivatives are contained in some way. Even polynomial derivatives are contained, because eventually they die. Are you with me? What is the derivative of secant? Secant tangent. And then what's the derivative of secant tangent? That's the product rule. And then what's the derivative of that? And what's the derivative of that? Would you call that a contained situation?
It's infinite.
No. So its own derivatives don't play well with itself and each other. So that's why there's very few functions that will work with that undetermined coefficient method, assuming with the form of yp. So cosine and sine do, e does, polynomials do, and that is basically it. Right? Natural log wouldn't. Right? That's not contained in any way. It's not like terms, and it doesn't disappear. It becomes 1 over x, and then, oh shit, it doesn't ever go away, and it doesn't really play with itself well. Does that... I know the phrase play with itself well is weird, but play with it and its own derivative as well. Right? So secant sucks. Its derivatives are gross. They're not going to be like terms with itself, so that's why I can't use that. So that's why I said variation of parameters is the method. Section 4.4 is a shortcut method for certain functions. So every problem 4.4 you could do 4.6 on. But why would you? Because there's a shortcut. Now, some people might like the 4.6 method better for certain things, which is fine. There's nothing wrong with that. That's beautiful. I mean, that's a little tier. Does that make sense? I mean, that's... So there's only certain functions you can do that with. Secant x, you cannot. So that's why you have to use the general method, variation of parameters. Yeah. Which one's that 4C? Yeah.
Yes.
You see how the I don't know if you can really see that answer. I think I was getting a little loopy here at the end, but it's 1/3 x e to the x sine x plus 1/3 e to the x cosine x times natural log of cosine x. That is not something I would expect. So there's no way in hell I'd be able to write yp. I'm going to assume it looks like that. What the hell would that be? Yeah. Yes?
Can you explain number 2?
Oh, so again, when we first, right after we did 4.2, and we got into 4.3. 4.3 is where we first did the e to the mx method. Remember that? And I don't know if you guys remember this. There's a problem like I did a problem like this, and this is going to be the auxiliary equation would eventually lead to m squared plus 6m plus 9 is m plus 3 squared. Is that cool?
Yes.
So you got m equals -3, -3. So this is before we talked about the cases. This is before we talked about what to do. We didn't know what the shit to do. But we had just come out of a section that said if I have one solution, which is all I had. In fact, I don't need to see here. It'd be e to the -3x. I then have a method to find the other one, right? That's the 4.2. And we realized in the process that the thing that came out that happened would happen every damn time. which was we ended up multiplying by x to get the second one. So that's why the second one is going to have to be x times that. So that's where it comes from. Where does it come from? Reduction of order. And then we make it into a rule because it's a pattern that will always occur the same way. It's something that will always happen that way, so we make it into a rule. Is that cool? Does that make sense? I mean, that's how most of math works. Is we go, does that always happen? Yeah, it does. All right, let's make a rule out of this shit.
So we can forget 4-1 is what you're saying.
Uh-huh.
So we can forget 4-1 what you're saying.
Oh yeah, well, 4-1 was just, wasn't 4-1 another frustrating section?
Yeah. Here's
Yeah.
what solutions look like.
Yeah.
Sort of thing.
But 4-1 is in every problem, right? It talks about if you have multiple YCs, you can just add them together and make one big answer. And if you have YPs for that, just add those in there too. It's a superposition thing, right?
Or was that? Oh, that's 4-2. Sorry. So I meant to say we can just forget 4-2.
Oh, you wish. Yeah.
Forget 4-2.
You wish.
Go show on a test.
Go to the shortcut now.
Did I? Yeah, I didn't have an explicit reduction of order problem on here, but you know there will be. I mean, I made it into a conceptual question. That's because reduction of order isn't that horrible of a process. Variation of parameters is a little bit worse because you have two pieces to kind of work with, and you have to remember what the form of the U1 prime and U2 prime are. Whereas the reduction of order is just you can sink your teeth into it. You can follow it, you can do it, you can plug it in, you can do shit.
It's easy to make mistakes.
Well, that's always true.
It's easier messed up though with the procedures for the variation parameters. I know.
Oh yeah, good lord, man.
We add stuff, we multiply stuff together, and they take integral of that, and like.
So this is like when I teach matrices to my 110 students, and they're like, you said this would make everything better. You suck. Because they forget to write a negative, and their answer becomes 2.87664. You know. So I tell them on a test, if you make a mistake, and you think you did something wrong, and you can't see what it is, at least show me you know what to do. Show me you know what the steps are. Show me you know what you're allowed to do. Show me you know what you try to go as far as you can. So on the variation parameters, if you think you made a mistake and you end up with an interval you can't do, at the very least, tell me what you would do next. Work the other one out as far as you can. Come up and ask me. Sometimes you're like, I can't see it, and I'll look and I'll say, oh, you got a negative, or it's not C, it should be CX, or something like that. You guys with me? So I have no problem with you coming up and saying, I know I did something wrong here. Can you see something? Because one thing about teaching for so long is you know kind of what to look for. There's mistakes that certainly happen all the time. But yeah, there's always an easy mistake that can happen. You cannot control for that, right? So the focus is always, for me, I grade based on, do you understand the concept? Do you understand the process? Right? Getting the right answer is like a bonus. Okay. Now, because you're not actually building bridges yet, no one will die because you missed number 5. Like, you missed number 5, 28 people died. You got the extra credit, 3 of those came back to life. I don't know.
You find God now.
Yeah, both my conceptual questions were about reduction of orders. Now, I'm not saying I do this on purpose, but I don't know if you ever noticed that sometimes bonus questions or further questions have references to processes you're supposed to use in an earlier question. Have you guys ever noticed that?
Yeah.
I mean, sometimes we do that. We don't even realize we do it as a teacher. We're just asking a conceptual question, and if you look ahead, you're like, oh, that's what I'm missing about this. That's another little thing you can do, is look through the whole test and see if there's clues. Maybe now that I'm thinking about it, I'll make sure there won't be. But maybe I'll forget, I have a horrible memory.
All right, stop talking about it.
So now's the time to ask any homework questions that were really bugging you. Could do some examples. How much time we got left? We got time. If you're more interested in leaving early, you could do that. That's always an option. Everybody knows now that I'm in the office starting at 4:30 on Monday, Wednesdays, and then I shift over here at 5 o'clock. All right. Especially today because we had no AC in the office. In fact, at one point I looked at it and it said emergency heat was on. I was like, no.
So I was doing a problem homework.
Yeah.
This is integrating problem. How do you do the integral of square root of 1 minus x squared?
Ooh.
I didn't know how to
Ooh.
keep going from
Is that from a homework problem?
Yeah, 4.6, number 18. I got all the way down to there.
4.6, number
18.
18.
I got stuck on that. For
Yeah, I
the-
can't remember. I think. Well, all right. I'm going to pretend like.
Oh, yeah.
This is after I got the u prime 2. This
Huh?
is supposed to be u prime 2.
But this is what you're working on directly right now, right?
Mhm.
Okay.
It's like substitute trace.
See,
or
there's
something.
yeah. Wow. All right.
I thought it was arctan for a moment, but it's not.
Nope.
Oh, you
Ten
didn't
is
get,
one over.
Yeah.
you didn't get x times that?
Now, some of you guys
No.
are.
Substitution.
They messed up the problem.
Some of you guys realize that there are some integrals in the front of the book that you won't be able to access when you're in a test.
Yeah.
You know, so you should probably make sure you can actually do this yourself. So, like you said, how do you know it's trig sub? What kind of gives that away?
1 minus
Yeah,
x squared.
1 minus some function squared. That sounds like a trigonometric identity, right? So, what am I going to let x equal then?
Sine, maybe? Or
Yeah, sine, because 1 minus sine squared is
cosine?
cosine squared. So it was 1 plus x squared. What trig identity is that related to?
Cosine?
Tangent. Cosine and sine have to be subtracted from 1 because they both become 1.
Tangent.
So it's 1 minus 1 is the other one. 1 plus x squared would be let x equal tangent. And if it was x squared minus 1, secant, because that's actually the same identity, right? 1 plus tangent squared is secant squared.
This is 2 part of this.
This one, not so bad. dx would then be what?
The first one, sorry.
This is the second part of it. Then cosine.
What's dx then?
Cosine
Cosine?
theta. Theta. Theta.
Now I have everything I need. So I get the integral of the square